Hey, this is Robert Naini, your spray foam advisor. And today I want to talk about air leakage and natural air changes per hour. And specifically, when we build structures and during the construction process, there are a lot of imperceptible holes and points where air can easily move inside and out of a building enclosure. So as the pieces and the components that we're assembling come together, there's minuscule areas, very tiny areas, oftentimes where we can't even see them, where air is able to move inside and out, depending on the climatic conditions, depending on the pressure differences. You might have air infiltration into the structure or air exfiltration out of the structure. This can be quantified in terms of air leakage and air leakage rates. And the number one way of doing this is actually with the blower door test. And they put a fabric over a door and they put a fan inside that fabric. And this is a blower door test assembly kit. And then you're able to pressurize the structure and measure the leakage rate at a specific pressure. Most commonly, the pressurization that's used is 50 pascals. And actually, a lot of builders don't know that air leakage testing is now mandatory in the 2015 codes. So in the 2015 codes, they actually say that you are to have less than 5 air changes per hour at 50 pascals in climate zones 1 and 2, and less than 3 air changes per hour at 50 pascals at climate zones 3 and higher. So these structures, what this means, what is, air changes per hour, what does it actually mean? Well, it's a reference to the volume of the total structure. So 5 air changes per hour at 50 pascals for climate zones 1 and 2 would mean that the whole entire volume of the structure would exchange with outside air every hour at this high pressurization. Now, this is not how a typical building operates. Now, when you take these numbers and convert them back to an approximation, an estimation of the natural air leakage rate, you're typically going to be somewhere for a tight building under 0.2 natural air changes per hour, and then of course leakier structures will get up over even 1 air change per hour in some cases for really leaky buildings, and possibly even higher than that. But that's natural air change per hour. So that's as the structure sits there without having a massive pressure applied to it. What is the natural occurrence with wind effects and with pressures from the outside of the building? What's an approximation of how that building will leak over time? That number is very hard to measure for a structure. So typically what happens is someone can conduct a blower door test at pressurization and then take that number and use a mathematical model or mathematical manipulation to kind of approximate or estimate what the natural air changes per hour would be. Now, it's not exact. It is just an approximation. That's the best we can do with math involved in that process because we're not actually measuring it. But the idea is that we can take the pressurization number, the air leakage rate at pressure, and then convert it back to kind of give us a good idea of what it would be at natural pressures. So that's the overall concept. So there's 2 different terms there that I've kind of run together a little bit. So we have the pressurization at 50 pascals, which is determined by the blower door test. And then there's another concept, the natural air leakage rate, which typically will be less than 1, less than 0.2 or 0.3 air changes per hour for a tight structure, and then could be as high as 1 or more for a very leaky structure for that, that natural air leakage rate. So what does this mean? Natural air leakage per hour. So at 0.2 natural air changes per hour, this is where many of our spray foam homes will be found as for a natural air leakage rate. That the approximation or estimation will be less than 0.2 air changes per hour. And it's because all those cracks and crevices that I mentioned before, where a typical structure would have minor leakage spots or minor leakage points for exfiltration or infiltration, you don't have those with spray foam because it's the air barrier at the same plane as the insulation. You significantly reduce the air leakage and the effects of the natural air changes that occur in a structure. So the air leakage rate goes down and you don't have to condition as much air. So at 0.2 air changes per hour, that means it's going to take 5 hours for the entire volume of air to exchange with outside air. Now, it doesn't work like that. You don't have exactly the entire volume exactly exchanged with outside air in 5 hours. But once again, it's an approximation. Whereas with a structure that's more leaky, that has 1 air change per hour, that means the entire volume of the air exchanges with outside air every hour. Why is this important? So think about the effects on an HVAC system. So if you have to condition, if you have to cool or heat the interior environment, and you have 1 air change per hour, then on average, you're going to have 24 air changes per day that have to be heated and or cooled by the air management system. Whereas if you have a tighter structure with 0.2 air changes per hour, natural air changes per hour, then you're going to have somewhere in the neighborhood of 5 total air changes per day. So then the air conditioning system or the heater is operating much less. It's having to manage much less air, 5 volumes of the structure compared to 24 volumes of the structure, right? That's a 5 times difference. So the system, the air management system, has to work 5 times more, has to process 5 times more air, and that directly leads to energy, and it directly leads to money. So that's the idea behind natural air change per hour, and that comes from, kind of an approximation typically based on pressurization from the blower door test. This has been Robert Naini with Spray Foam Advisor. Thanks for checking us out. Catch us on some more videos. I love questions. Anyone out there, feel free to shoot in a question. I'll give you an email address right here for any questions you have. Send them to questions@sprayfoamadvisor.com. sprayfoamadvisorsingular.com. So questions@sprayfoamadvisor.com. Go ahead and send those questions in. I'll get to as many of them as I can, and I'll try to incorporate a select few into some of my weekly videos. And of course, if you like this video, go ahead and subscribe to the blog if you haven't already done that. Find us on YouTube and like and follow us there. And check us out on LinkedIn, Facebook, Twitter, Instagram. Find us on all of your favorite social media sites, and you can keep up with the words of wisdom coming out of Spray Foam Advisor. Thank you very much for joining us. I appreciate it. We'll catch you on some more videos. Take care.